In this video, we're going to take a look at what makes an organic molecule saturated versus unsaturated. Now, in a different video, I showed you that how carbon atoms can bond is very variable. There's lots of variety in organic compounds. So for example, we could have a carbon atom bonded like this to another carbon atom, bonded to another carbon atom like this. But remember that each carbon atom likes to have those 4 bonds. So it might look something like this, where each carbon atom has a total of 4 bonds. Now in between here, these 2 carbon atoms are sharing a bond, so it counts as 4 single bonds around this carbon atom and 4 single bonds around this carbon atom. So all of these carbon atoms have a total of 4 bonds. Now these ones here, these bonds coming out that aren't attached to anything, we might fill those in with hydrogen atoms. And sometimes organic chemists are lazy, they don't like to write those in, but we're going to put those in. We're going to draw in those hydrogen atoms just so that we can see them. And in a previous video, I showed you that hydrogen atoms like to form one single bond. And so here we have hydrogen atoms going all the way around this molecule forming single bonds. Now, we would say that this molecule, this organic molecule, is saturated. That is to say, it cannot have any more hydrogens attached to it. So I'm going to call this one saturated. It cannot have any more hydrogens added to it. So what does an unsaturated molecule look like? Okay, if we were to take this same molecule and just draw it a little bit differently. I'm going to start out with my 4 carbon atoms. Excuse me, my 3 carbon atoms. I can add, really. Okay, my 3 carbon atoms, and instead of having all of those hydrogens going around it, I'm going to put in a couple of double bonds like this. Okay, and now each of these carbon atoms likes to have a total of 4 bonds, so I'm going to go like this and like this. Okay, so 1, 2, 3, 4, 1, 2, 3, 4, and so each of these carbon atoms has got those 4 bonds. And I'm going to fill in these outside bonds here that aren't attached to anything to hydrogens. Like this. Now here we can see this one has more hydrogens, this one has fewer hydrogens. So we would say that this one is unsaturated. It could have more hydrogens attached to it. An unsaturated molecule. Now how many hydrogens could be attached to this? Well, you can look over here and you say, well, wait a minute, this one's got, let me see here, this has got 2 and 2, there's 4 hydrogens here, and this one has got 6, 7, 8. This one's got 8 attached to it. Okay, so if this has got 4 and this has got 8, then clearly there must be 4 that we could add to this. So how would we do that? Well, we would break these double bonds. So whenever we break one of these double bonds like this, I'm going to break a double bond like this, then I'm going to end up with another bond here, because remember, each carbon atom likes to have 4. And I'll add another one here. And then I'll break this one like this, and I'll end up with another bond and another bond. And I better then put in my hydrogens like this. So by adding all of these hydrogens, I've now made this saturated. I'll go like that. Okay. Now the general formula for this, if I were to say a general formula for saturated hydrocarbons, here I've got 3 carbons, so I'm going to say C3, and then I have 8 hydrogens, so that becomes H8, like this, okay? Now if I were to take a look at another saturated hydrocarbon, let's just do two carbons. So I'm going to go carbon, carbon, okay, 2 carbons, and then remember each of these like to have 4 bonds, so I'm going to go like this like this, like that, okay? And I then fill that in with hydrogens. I'll go hydrogen, like this. And then my formula for this, I have 2 carbons, so this becomes C2, and I've got 1, 2, 3, 4, 5, 6 hydrogens, so H6, like this. Okay, so now the question is there a pattern? Is there a pattern, mathematic pattern, here for my saturated hydrocarbons and their formulas? And it turns out there is. The general pattern for these saturated hydrocarbons is going to be carbon, some number of carbons, so Cn plus Hn. Okay, so N would be the same for each of these, but we notice here that there's twice as many hydrogens as carbons plus 2 more. So I'm going to go 2N plus 2. Okay, and let's just see if that carries over here. So here, this would be Cn, and this would be 2N plus 2, because there is twice as many hydrogens plus 2 more. So twice as many is 4, 4 plus 2 is 6. So our general formula for a saturated hydrocarbon is CnH2n plus 2.